Amongst the more signal achievements of recent anthropological research in the field of prehistoric Europe may be counted the discovery of a partial cranium of a fossil human at the site known as Gruta da Aroeira, situated within the borders of the modern Portuguese realm. This singular find, henceforth denominated the Aroeira cranium or Aroeira 3, presents itself as a contribution of the utmost import to the present inquiries into the evolutionary descent of the species of man designated as Homo neanderthalensis, commonly called the Neanderthal type of man. The Aroeira fossil, although lamentably fragmentary, has nonetheless occasioned considerable discussion owing to the curious admixture of characters it exhibits, some suggestive of the Neanderthal form, others more closely allied with those forms formerly considered as Homo erectus, and still others of a perplexing intermediate condition. It is with a certain spirit of restraint that the learned discoverers have refrained from appending to the fossil any definitive taxonomic assignation. This reticence may, at first glance, appear to betoken a lack of interpretive zeal, yet on closer inspection may be regarded as a commendable caution against the over-hasty multiplication of species, a practice perhaps too eagerly embraced in earlier years of our discipline. Encased in a hardened mass of conglomerate rock, the fossil required considerable mechanical effort, including the removal of a great stone block, which was conveyed to Madrid for laboratory preparation. Once liberated, the fossil comprised the posterior portion of a calvarium, a portion of the nasal floor and upper maxilla, and 2 fragmentary teeth. Associated with the fossil were a number of lithic artifacts, notably bifacial hand axes of the Acheulean tradition and faunal remains bearing evidence of thermal alteration, presumably by fire. These associations suggest that the individual to whom the fossil belonged was a member of a cultural community not devoid of technological sophistication. The fossil's antiquity was determined through uranium-thorium dating of adjacent speleothem deposits and of calcitic encrustations upon the fossil itself. The former yielded an age of approximately 406,000 years, with an allowance of plus or minus 30 millennia, whilst the latter returned a mean of 390,000 years, plus or minus 14,000. Thus, it may be affirmed with confidence that this individual trod the Iberian Peninsula during the early Middle Pleistocene, a period contemporaneous with other important hominin specimens. The discovery of the 400,000-year-old cranial fragment in Gruta da Aroeira, Portugal, has renewed debate over how best to interpret and classify hominin fossils from the Middle Pleistocene. Designated Aroeira 3, the specimen exhibits a mosaic of primitive and derived traits, but does not conform neatly to any established species, including Homo heidelbergensis or early Homo neanderthalensis. This ambiguity challenges long-standing taxonomic frameworks and forces a re-evaluation of the evolutionary processes shaping archaic human populations across Europe during a period of profound climatic and genetic transformation. Aroeira 3 includes a portion of the cranial vault, sections of the nasal floor and upper jaw, and 2 incomplete teeth. While incomplete, the fossil reveals several traits typically associated with different phases of human evolution. These include a continuous brow ridge reminiscent of specimens from Bildungsleben, Germany, a short mastoid process like that of the Steinheim skull, and a bony projection near the auditory canal also present in Cranium 5 from Cima de los Huesos in Spain. Yet, Aroeira 3 does not clearly align with any of these fossils. It lacks certain key features diagnostic of Neanderthals, such as a pronounced occipital bun or retromolar gap, but also deviates from more primitive forms. This morphological ambiguity is not unique. Similar patterns have emerged from other Middle Pleistocene finds in Arago, France, Ceprano, Italy, and Petrolona, Greece, suggesting that these hominins shared a common but regionally variable gene pool. The traditional impulse to assign fossils to discrete species has been increasingly challenged by advances in ancient DNA research, particularly from Cima de los Huesos. At this site, dated to approximately 430,000 years ago, researchers successfully extracted mitochondrial DNA from multiple individuals. The results were unexpected. While the Sima fossils exhibit many morphological traits that anticipate classic Neanderthals, their mitochondrial DNA does not fall within the Neanderthal lineage. Instead, it shares a deeper ancestry with the mitochondrial DNA lineage later found in Denisovans, the enigmatic sister group to Neanderthals in Asia. This paradox, Neanderthal-like morphology, combined with a more archaic mitochondrial genome, suggests that the Neanderthal lineage was still in a formative phase during the Middle Pleistocene. The divergence between nuclear and mitochondrial signals may reflect incomplete lineage sorting, or, more intriguingly, ancient gene flow between deeply separated populations. Could Aroeira 3 represent one such population, one that contributed morphological traits to the Neanderthal lineage but retained an older mitochondrial DNA lineage? We do not currently possess genetic data from the Portuguese fossil, but its geographic position on the western fringe of the continent raises the possibility that it belonged to a genetically diverse and regionally distinct group that only later merged into the Neanderthal metapopulation. To understand the context in which Aroeira 3 lived, we must consider the massive climatic shift that occurred during this period, known as Termination 5. This event marked the end of the harsh glacial conditions of marine isotope stage 12 and the transition into the more temperate marine isotope stage 11, approximately 424,000 years ago. Termination 5 represents one of the most significant deglaciation events of the Quaternary period and would have transformed the European landscape, opening previously glaciated regions to hominin migration and expansion. During marine isotope stage 12, vast ice sheets rendered much of northern Europe uninhabitable, concentrating archaic human populations in southern refugia, particularly the Iberian, Italian and Balkan peninsulas. These regions likely acted as evolutionary incubators, where populations diverged in relative isolation. As Termination 5 progressed, these barriers dissolved, allowing for secondary contact and genetic exchange between previously separated groups. The mitochondrial DNA from Cima de los Huesos may be a snapshot of one such southern refugium lineage, while Aroeira 3 might represent a contemporaneous group whose evolutionary fate was similarly shaped by climatic oscillations and isolation. This scenario helps explain both the morphological variability and the complex patterns of gene flow observed in European hominins from this period. Rather than distinct, tree-like branches of evolution, Middle Pleistocene hominins appear to have formed a reticulated network, a web of interbreeding and divergence shaped by alternating pulses of glaciation and interglacial warming. The Aroeira 3 fossil was discovered alongside Acheulean hand axes and faunal remains bearing burn marks, suggesting that this population possessed both stone tool technology and fire use. These cultural traits are not unique to Portugal. Acheulean technology had spread widely across Africa and Eurasia by this time. However, their appearance in western Iberia, far from the supposed point of origin in the Levant, demonstrates the pan-continental diffusion of technological traditions. The presence of fire at the site implies a degree of cognitive and social complexity, perhaps comparable to that of the Cima de los Huesos people. The use of fire and standardized bifacial tools could indicate shared cultural practices or parallel innovation. Either interpretation underscores the importance of cultural transmission among archaic human groups. Moreover, the co-occurrence of these technologies across multiple populations suggests that they were not the unique inheritance of any one hominin species. Rather, they were part of a broader behavioral repertoire shared across an interconnected Eurasian population. This again challenges the concept of clear-cut species boundaries and reinforces the idea of a dynamic and fluid human population structure during the Middle Pleistocene. The discovery of Aroeira 3 underscores the limitations of rigid taxonomic labels in the face of growing evidence for genetic and morphological continuity across the Middle Pleistocene. Fossils like Aroeira 3, Arago 21, Steinheim and Petrolona resist tidy classification because they are not outliers. They are representatives of a broader, more complex evolutionary reality. Rather than envisioning discrete species evolving in isolation, it may be more accurate to picture regional populations of archaic humans interacting through cycles of isolation and reconnection. Periods of geographic separation, as during marine isotope stage 12, may have allowed local populations to develop distinct traits. Subsequent climatic amelioration, as during marine isotope stage 11, facilitated contact and gene flow, reintegrating these differences into a larger shared gene pool. This population structure, dynamic, overlapping and shaped by the rhythms of climate, is visible in both the genetic legacy and the anatomical traits of fossils like Aroeira 3. While it may not be possible to assign this specimen to a specific species, it serves as a critical data point in reconstructing the Neanderthal lineage. It represents a hominin population that likely contributed to the mosaic ancestry of later European populations, both Neanderthal and perhaps early modern humans. The authors of the Aroeira report, doubtless influenced by such modern sentiments, have chosen not to classify the specimen as a new species or even to declare it unequivocally as Homo heidelbergensis, a term frequently employed for Middle Pleistocene Europeans. Instead, they suggest that the fossil belongs to what might be called a morphological continuum, one in which gene flow and interbreeding, occurring over thousands of years and across vast territories, produce no sharply delineated species boundaries. This hypothesis of a unified humanity across the Old World finds some support in recent genetic studies, which demonstrate extensive admixture between archaic populations, including Neanderthals, Denisovans, and the ancestors of modern man. If such intermingling was widespread, the morphological variation now observed in the fossil record may reflect not speciation, but population structure, environmental adaptation, and cultural differentiation. Thus, the Aroeira specimen may be regarded as a testament to the interwoven nature of human descent. It presents an anatomical ledger of features both primitive and derived, whose combination defies the artificial pigeonholes once used to parse the ancient family tree of man. Is Aroeira 3 the grandfather of Neanderthals? In the traditional phylogenetic sense, perhaps not. It lacks the full suite of derived traits and cannot be placed confidently on the direct ancestral line. But as a member of a broad and varied population that helped shape Neanderthal evolution, it may indeed belong to the larger ancestral pool, the diverse and regionally structured population from which Neanderthals eventually crystallized. In this light, Aroeira 3 is not an evolutionary dead end nor a taxonomic anomaly. It is a testament to the complexity of human evolution during a pivotal period of climatic upheaval, population fragmentation, and cultural innovation. As future discoveries and genetic analyses emerge, the legacy of fossils like Aroeira 3 will be key to understanding not just the emergence of Neanderthals, but the broader story of human evolution in Pleistocene Europe. This fossil stresses the need to overcome the species question in order to understand the humans living in Eurasia about 500,000 years ago. Not all anthropologists entirely agree with this idea, though. Given that some of the authors are known to be unenthusiastic about assigning distinct species names to archaic human fossils, it's not surprising that the paper sits on the fence taxonomically. But to be fair, the specimen does show a new mix of traits for this period of time, and does differ from the folks down the road at the Cima de los Huesos in northern Spain, Chris Stringer, a paleoanthropologist at the Natural History Museum, London, said. Dr. Stringer also points out that the fragment is missing some of the key parts of the skull that paleoanthropologists used to classify early humans. And if these features were there, Stringer would use them to assign a species name to the specimen, whereas the paper's authors likely would not, he says. Thank you for watching.